Okay, here's B2 bacterial growth. Not very long on this. Bacteria are a type of microorganism. They're pretty small, maybe only 1 to 5 micrometers large. A micrometer is a millionth of a meter, or to give you another idea of that, a thousandth of a millimeter. So some of these bacteria, you could fit 1,000 of them into 1 millimeter. Some of them are slightly larger, some are slightly smaller. Various shapes of these things. Some are kind of ovally shaped bacillus, some are roundy shaped, some have got tails or flagella and can move around. Many different types of bacteria, most of which are actually pretty harmless to us, the majority of them really. Our skin is absolutely covered in bacteria. We've got lots and lots of them. Your lower gut, your lower intestine, even if you took perhaps just 1 centimetre of your colon, there are probably more bacteria there than there have been people born ever. Okay, just living in your gut. There are more bacterial cells in your body than there are cells of you, if you like. There are more bacterial cells in your body than you've got your own cells. That's how common they are. Most of them don't cause us any problems. They like being in your body. A couple of reasons. It's warm, a nice ideal temperature, around about 37 degrees generally speaking. It is moist. Bacteria like moist conditions. This is why one of the ways to preserve food and prevent it rotting is to dry the food out. If you think of something like dried pasta, for example, dried rice, it can last a long time. There's no water there, so the bacteria can't live and thrive there, and your food won't go bad. And there's also a nice supply of nutrients in your body to keep the bacteria going. Something called the bacterial growth curve that you need to know. And it's a bit of a graph. Nothing too difficult. Okay, time on the bottom, and up the side, the number of bacteria. If you start off with a few bacteria, we don't have many, so perhaps we start off with just maybe 1 bacteria. Let's just come down here. And bacteria reproduce by making copies of themselves, so they double up to 2, it doubles again to 4, 8, 16, 32, 64, 128, 256, 512, 1024, and so on and so on. You can work all these things out if you really want to. It's called an exponential increase. You can see the numbers are all, we've got halfway down, we're only up to 64, but the next half we've gone up to 4096. In other words, what's happening is the rate that they're increasing is getting bigger and bigger and bigger. Okay. On a graph, this is sometimes called the growth phase. This is where we've got rapid growth of the bacteria. Lots and lots of bacteria being produced. We then start to find that it starts to steady off into what's called the steady phase. Now, what's happening here is the bacteria is starting to die off. Why? Well, they may be running out of nutrients. There may be so many bacteria that they're eating everything else. If you like, they don't eat, but they're absorbing all the other nutrients. They might run out of space. But the amount of new bacteria you're making, because these are still dividing, is being equalled out by the amount that are dying. So we're not getting an increase or a decrease in numbers. Eventually, we might start to completely run out of nutrients, and the number of the bacteria will go down. This is sometimes called the death phase. Okay. So let's just put something in there. We'll run out of nutrients. It could also be that certain chemicals that bacteria make as side products, maybe they've built up and start to poison the bacteria. If that sounds odd, if you think of something like yeast, and yeast aren't a bacteria, yeast are a fungus. If you're using yeast to make alcohol in fermentation, if you've got them in a jar, they will start, in the presence of sugar and water, they'll start producing alcohol. Alcohol is a toxic substance, and it will build up to a point where the yeast will die. So it's not unusual for the idea that organisms make some kind of waste product that begins to poison them. So this bacterial growth curve if you can explain what's happening at each point, then you've understood what the bacteria are doing.